So our next three talks are themed around development in R. And so first up, we're going to have Jonathan McPherson.
Thank you. My name is Jonathan McPherson. I'm a software architect at Posit. And today I'm going to talk to you about 10 years of RStudio and what happens next. So this is going to be a play in 3 acts. I'm going to talk a little bit about RStudio. I'm going to talk a little bit about Positron, which is our kind of next IDE. And then we're going to talk about the future for a little while. So we've arrived at Act 1 of our program, Act 1, RStudio. So I want to go back in time a little bit to the year 2013. So for those of you who don't remember, this was our president, Mr. Barack Obama. We had just elected a new pope. And I don't remember, but I think gas was 83 cents a gallon. Remember that? And I had just started working at a small startup called RStudio. This was our website back in 2013. And I was very excited about starting at this new little company. And when I told all my friends and family about it, they all asked me exactly the same question. And I imagine it's the same question you've gotten from a lot of your friends and family. What is RStudio? Right? So fast forward to today, June 2025, RStudio has been really successful beyond our wildest dreams. It is used about 5 million times a week, and that usage is only continuing to grow. So I thought I would take a little while and be self-indulgent and ask, why it has been so successful, and what are some things that we've applied to Positron, and some things that you can apply to your own software. The first thing is that RStudio was made by an R user, not a focus group. This is JJ Allaire, who is one of the original authors of RStudio. And JJ is not, he didn't create it as part of a focus group or a committee. He was an individual user trying to address an individual need. And if you look at software that is really successful, this is often how it starts. RStudio is also free and open. So we've made it available for every platform, also the web. We license it very permissively. And we're also a public benefit corporation. And what that means is that as we built and developed RStudio, we've been able to do it based on our mission, which is to bring open source data science tools to everyone, over our profit goals. So what that means is that as we've developed the software, we've been able to make decisions that are the best for users, and we don't need to kind of slip into those venture capital driven dark patterns or revenue grabs. RStudio is built for a single purpose. We found that a lot of people that work with many different programming languages will use kind of general purpose tools to write R code. So you can do this, right? I mean, you can use general text editors to write R code, but you will never beat a tool that is designed specifically for the task that you're using. If you think of these general purpose tools as a Swiss Army knife, RStudio is something more like a screwdriver, right? You use RStudio for R, it is, and I quote my slide, utter bliss. RStudio works with data and results, not just code. We were one of the first tools, I think, that recognized that R is a lot more than just code, right? When you're writing R, you're also working with data and output and results and reports. And RStudio was very successful in part because we combine all these things into one environment. It starts ready to use. By show of hands, how many of you have ever opened RStudio in order to add 2 numbers? Anyone else? Yes. Have you ever done that with any other program on your computer besides perhaps the calculator, which I may remind you is also installed on your computer? Probably not, right? RStudio's philosophy is that you should be able to install R and install RStudio and open it up and simply have it work. RStudio embraces this idea of convention over configuration. This screenshot is of Internet Explorer, for those of you who remember that software. And I actually worked at Microsoft at the time that this kind of thing was going on. And I learned that if you give the people the power to configure your software too much, they just can't help themselves. They do this stuff, right? So our studio stays simple and easy to use. It has a very predictable layout, and it works the same no matter whose computer you sit down at. Engineers and customers. There's this thing that tends to happen in organizations as they grow, where the engineers and the people that are actually like buying or using the software just kind of drift further and further apart. And I just want to remind you that this is not a law of physics. Like it's a tendency, it happens, but it doesn't have to. And one of the values that we've embraced at our studio is we keep the engineering team very connected to the people using the software. If you today go post an issue on the RStudio GitHub, within a day or two, you will receive a response from someone who actually develops the software, tests it as part of their day job. Like, you can do this. You can keep your engineers connected to your end users, and that develops an empathy in the engineers that really cannot be replicated any other way. It's vital that you have the people building the software understanding and communicating with the people that use it. Along with that, listen to your users. We have a public GitHub, and a lot of our best ideas and features in our studio have come from end users who have been kind enough to tell us where we're missing features, where they're having problems, and so forth. Finally, empower the community. Back in 2016, we created these things called RStudio add-ins, and I was completely blown away at the response to this feature. People used our add-in infrastructure, which, by the way, isn't that powerful, in ways that I completely did not anticipate. If you give people just a little bit of creativity and control, you will be always impressed at what they come up with. All right, to sum it up, if you want to build great software, these techniques don't work for everyone, but I think there's some of the things that have made our studio so successful. Start small, start organically. You don't try to make something for everyone, especially not at first. Like if you try to make something that solves everyone's problem, you're going to wind up with something that solves nobody's problem. But develop freely, develop in the open. Make sure it's really easy for people to use your software, like to acquire it and use it. It sounds simple, but you'd be surprised at how many software packages don't follow this. Again, connect your engineers directly with the people using the software. I wish I could underline this, but I forgot to. Make it simple to start and use your software. People will not use it if they open it up and it doesn't work. Or they open it up and they have to answer a questionnaire before it works, right? And finally, like the community, which is all of you, is a tremendous source of power. You know, if you empower and love and listen to your community, you can make really great software. We've arrived at Act 2 of our program, Act 2, Positron. So I just talked for too long about why RStudio is great, so why did we make another IDE? So the answer is that RStudio, though it is wonderful, has some limitations. For one thing, it is single session. You can only run one R inside of it. It's single language, right? It really only works for R. You can use Python in RStudio, but it requires running Python inside of an R session, which is a kind of a weird thing to do. RStudio has limited IDE features, and this is largely because it has a bit of a zero-sum contest between data science and IDE features. So the team that builds RStudio kind of has to choose between whether we want to do data features or more traditional IDE features like searching and replacing in files and like browsing folders and that kind of a thing. So Positron's goals were really to overcome a lot of those limitations of RStudio. It works with multiple languages, R and Python. Our goal is to bring the best data science tools to all data scientists, not just our users. Obviously, it has multiple sessions. We have inherited a really nice set of data science IDE features from VS Code. And also, we want to embrace this idea of tool unification. You know, we looked at a lot of people that are writing R and Python code and find that people would use a lot of, well, maybe like one or two tools like RStudio that were specific for data, and then they would use something like VS Code for everything else. And we wanted to make an environment where people could do most of that work in a single tool. So I'm not going to belabor Positron a whole lot because I think there's already a workshop on it, but I did want to spend about 5 minutes talking about what comes next. So I want to talk about composable and open tools. Again, we love RStudio, but it is a bit of a monolith. It has a lot of great features that are all combined together into a single program. So let's think about the stuff that RStudio does, right? In RStudio, you can run our code, you can debug it, you can format it, you can view data, you can link your R code, it has autocomplete, you can look at variables. Like these are all capabilities that are very tightly fused to RStudio itself. You can't use any of these things outside of RStudio. So one of the things that we're moving toward in the future is this idea of more composable and open tools. So in the Positron project, we've taken some things like data and variable viewing, and we put those inside of Positron itself. But a lot of the R-specific tooling, like code formatting, auto-completion, debugging, execution, linting, all this stuff, we've actually created separate MIT licensed packages that allow you to take those capabilities that we developed for Positron and use them in other places. And this is possible because since RStudio's inception, there's been an explosion of open tools and protocols that allow us to connect these things together. So for example, have you ever browsed our code on GitHub? Probably. If you have done this, you have used code that we wrote specifically for Positron. So we actually contributed some of our R parsing code back to GitHub, and they hooked it up to their code navigation system. So you can now browse symbols inside of our code as a downstream effect of some of the work that we did for Positron. Positron's R code execution engine, which is called ARC, we made it available to anyone to use as a Jupyter kernel, and it powers things like the R experience in the Z editor. So we're bringing the code execution engine we wrote for Positron, made it available, and lots of other editors and systems are picking it up as a way to execute R code. Even in RStudio, so we wrote a really nice R code formatter for Positron, and that code formatter is also available inside of RStudio. So we get a lot of kind of cross-pollination between the IDEs. So what I'm saying is Posit loves R. I think there's been kind of a meme that we're investing a lot in Python, which is true. But it is not true that we are abandoning R, and we're probably spending more on the R ecosystem than we ever have. Sorry, 1 second. We're probably spending more on the R ecosystem than we ever have. You know, we're developing these open composable tools so that not just people who work in RStudio, but our users who use any tools can benefit from the systems that we're making. So I always get this question, what about RStudio? So I'd like you to maybe think back to the slide that I did earlier, where I talked about specific and general purpose tools. And the truth is that even though Positron is really good at both R and Python, it's kind of what we made it for, it will never beat a really like R specific tool like RStudio for some use cases. That we have to make trade-offs to accommodate other languages and platforms that we didn't have to make with an R specific tool. So RStudio is always going to be the best place for some R workflows, and we're continuing to invest in it and cross-pollinate it with Positron, as I just showed. I'd be remiss if I didn't talk just a minute about AI in your IDE. Honestly, we love this, but we're also, like all of you, tired of hearing about it. So I won't belabor it, but I will say that we're bringing a lot of AI features into Positron and RStudio, and finding that it's really impressive how these models can perform if you put them inside of an IDE. Because inside of an IDE, they have access to your code, your data, your coding style, your computational environment, and they can pair with you to accomplish your goals. In a lot of ways, I think this is a vindication of the code first philosophy that Posit has always embraced. Code is what models read, it's what they write. And so this kind of code first approach to data science that our users and developers have works really well with the language model paradigm. So with that, I was going to do Q&A, but I understand we're holding that to the end. So we'll go to the next speaker. Thank you very much.
In the way.
Thank you. So next up, we have Ben Matheson with GitHub Actions.
Awesome. So my name is Ben Matheson, and today I'm going to talk about supercharging your work with GitHub Actions. I work as a data analyst for the Anchorage Innovation Team. We're a small team inside city government that uses data science, human-centered design, and technology to help improve the lives of residents and help city departments do their best work. I've always struggled with getting things off my laptop and into the world where it can do, where it can have its most impact and be its best. A lot of times there's just enough friction that things get stuck and things don't get deployed. But with GitHub Actions, you've got a lot of great ways to break down those barriers and get your code into the world where it deserves to be. So game plan for today is to get into what is a GitHub action, how they work, explore the anatomy of an action, get into that in depth with a snow tracker, and then show off a little bit of a starter action here. So thankfully, we've covered GitHub Actions a little bit, but what is GitHub Action? I think of it as a good way to automatically run code, but you're doing it in the cloud, you're using GitHub Server. So basically, there's a bunch of Microsoft Azure infrastructure that GitHub has access to, and with that, you have access to it. You get a fresh, newly provisioned virtual machine anytime you want for free, 24 hours a day. And with that, you can use it for anything. You can keep your analysis current with regularly updating data. You can do your website builds, package development, ongoing testing, QA. I think that's kind of the core use case for GitHub Actions. What it's kind of truly meant to do is for people who are developing software and testing and deploying that constantly. But there's so much you can do. There's cron jobs, there's web scraping, R Markdown reports, portal projects, social media bots, email bots. Megan had a super compelling example with the running club. My entry into GitHub Actions was through that social media lens, where I wanted to share the stocks that Alaskans own through the Alaska Permanent Fund. It's the big $80 billion sovereign wealth fund. And I wanted to share that on a Twitter and Blue Sky bot. So I've got an action that processes a list of 14,000 stocks and grabs one to show off that Alaskans own $43 million worth of Alphabet, plus a bunch in Advanced Petrochemical, Osaka Titanium, and China Resources beer holdings. And because with GitHub Actions, you're connected to the internet, you can connect to live APIs. So the Alaska Department of Transportation has this network of road cameras that I think are meant to show off road conditions, but they're secretly really beautiful landscape photography bots. So 24 hours a day, while I sleep, this bot is grabbing photos and 24/7 posting those to the web. So how do actions work conceptually, at least? The best explanation I found came from our keynote speaker, David. He's got a really good tutorial about GitHub Actions. So first, you got to tell the code when it should run. And then you, once that's triggered, you start up your virtual machine, you install R, you install all the packages that you need to run your code, and you go ahead and run it. So it makes sense, to humans too who run code, but we're going to walk through that step by step. So anatomy of an action. You've got your workflow, your events, your jobs, and steps. Those are kind of the main ones. There's many more, but these are enough to get you started and running. So the workflow is this big YAML text document that maps out the who, what, when, where, and how of your action. This is the giant to-do list that defines your action. Looks something like this, but we'll get into it step by step. Your events, what triggers the code to run? And there's two main families of these things. There's those that come from GitHub code-related things. So if somebody pushes up code to a repository, if there's a pull request, if there's an issue created, that can be a trigger that kicks off your action and runs some code. Or there's a set of things that you can determine yourself. So you can set the schedule, you can create the cron job that has things run every day, week, month, whatever. Or you can kind of expose an API that every time that's hit, your code will be run. Your jobs wrap up the steps. There's this whole language and vernacular to GitHub Actions, which despite having used these for a couple of years, did not at all crystallize until I finally had to put this presentation together. So the way I tell myself is that you had one jobs, but there's many steps. And all of your steps in this job use the same runner. So the same virtual computer is used for your jobs. But steps, so this is where things happen. This is where you do the work. This is where you set up and you run your code. So workflow, events, jobs, and steps. That's where it all comes together. So now that we've reached the summer solstice as of yesterday, I think it's time that we redouble our efforts towards tracking snowfall for the upcoming winter. A little bit of context on why I think it's important to track snowfall. One is we got to make sure that we've got enough snow for sled dogs to run downtown. We want to make sure that there's absolutely the best snow for downtown sled dog racing. Also, City of Anchorage has over 1,000 lane miles of road that we need to plow, and we've had a couple of pretty extreme winters on both sides of the spectrum. 2 years ago, we got something like 11 feet of snow, which threw a lot of curveballs into city operations and the snowplow things. But now we've got GPS trackers on all of our snowplows, so we're able to track those across the city. And critically too, for me, I need to be able to track snow so that I can train for and compete in my local amateur cross-country ski races. So that is context for tracking snow. Zooming ahead to the report that we want, I want to track the current season's snow and compare it against history. So we can go back and pull some 73 years of history going back to 1952 and see how we compare historically to the last 73 years of winters. So we're going to be hitting an API that brings in the most current snowfall data, as well as reading in a whole bunch of historic data. So with our anatomy of an action, we've got a workflow, we've got some events, jobs, and steps. But first, to orient you on where we are. So there's a GitHub repository that is called Snowfall Report. And within there, I've got all the important pieces. I've got my snowfall Cordo file that just reads in the data and creates all the charts and graphs and calculations. I've also got a description file, which is going to have all of the packages that I need to install for that, as well as the historic data, and then kind of the Cordo YAML file that defines the project. To make my action, I go straight to the Actions tab. And so once you're there, you can create a workflow, and I'm creating a workflow called Snowfall Report. And it's here that I create my YAML file that has all of my steps, all of my triggers, and all of the things that occurred here. So we've got the YAML file here. That's our workflow file. And as a few people have said, YAML requires perfect indentation and perfect spacing and things like that. And if it's not perfect, it will explode. So with that, we want to have an event that runs every single day. So on this, we're going to use the on keyword and set that schedule with a cron job here. I think this is set for midnight every single day. I'm also including workflow dispatch, which I think allows me to run this manually. You can just run it by clicking within the repository. Very useful for when you're getting things set up for the first time. Jobs, you had one job, but many steps. So here we want to do a job called create report, and we're going to set the runner. So the runner here is going to be the Ubuntu latest, which is kind of the default for most of these cases. If you do have a very specific reason to run something on a Windows or a Mac runner, you can do that. It does chew through your available minutes, new credits just a bit faster, but you can certainly do that. I've also got this environment here, this weather token, so I'll get into that secret in a second, but I set that there with the runner. Okay, you had one jobs, but many steps. So let's get into our steps. We first got to check out our code. So we've got that Cordo file and those CSVs and all these things that we've got in our repository. We got to give the action access to that. So we check out our code. Next step, we got to set up R. Let's make sure that R is installed. And so with this, I'm kicking this off with the keyword uses. So we're going to use an action that a bunch of R maintainers keep in the rlib repository. And with that, there's a very helpful one called setup R. So with that, we're able to use the action from another group. Again, I've used GitHub Actions for a couple of years, but none of these words made sense until I had to actually put a presentation together. Uses, you're using somebody else's action to do that. With this, you're also able to specify what version, which is pretty helpful in this case. So doing R version 4.5. Next up, let's get some dependencies. So another one from the R GitHub repository, and that is going to be setting up all our dependencies. There's more than one way to do this, but my current favorite way to do it is this. You have a description file, and within that description file, just kind of a plain text, like one package on each line, I believe. It'll install and cache all of your dependencies at once. It takes a couple minutes the first time, but then it caches it and it has them ready to rip for the next time. You can also break your cache with this cache version right here. Next up, Cordo. We need to have Cordo installed. You can do it here, but you can also do it from the Cordo development team. So specifying a version of Cordo we want, and then render. We want to just wrap up a few commands that will render the Cordo project. And we want this to be HTML so that it can be saved to the repository and then shared online and be a real thing on the internet. When you're kind of setting up your first GitHub action, you're going to want to check out those actions that the R maintainers put together. And if you use a couple of these, you can get pretty far in terms of setting up R and setting up your environment. But finally, we've got an HTML file that we want to save to the repository. So we're going to push that HTML file to the repository and be able to publish that to the internet. And so with that, I should have a fully formed, fully prepared GitHub action that will create our snowfall report and take the latest data from last night and then compare it to the last 73 years of snowfall. With GitHub Actions, failure is definitely an option. So back in May, my email inbox looked something like this, which was just full of hundreds of messages from GitHub telling me that my actions have failed. They also very helpfully calculated some statistics for me in the month of May. So thank you very much, GitHub, for the affirmations. But the way to break through this is to get into your logs. And so to do that, you're going to want to, again, click on that Actions tab, and then you're going to see a big list of all of your runs. So I've got runs here that were 17 hours ago and 70 different runs. If you click on one of those runs, you can see your job. And I had this job, which was create report. Click in there. I've got all my steps, so many steps. But if you click into these individual steps, you can then see all of your logs. And I've got 2,400 lines of code just from the setting up Cordo. But you can usually get some pretty good error messages that tell you I've got some dependency issues going on, or I've got some permission issues going on. So you can run your actions, see your errors, and then go back and see if you can fix that. So secrets. GitHub's a pretty public place. It's a public place to have code. Your GitHub action logs are also public. So you want to make sure to keep your secrets secret. And the way to do that is with repository secrets. So you can create these right in GitHub. I've got this weather token. This is basically the API token to access the National Weather Service's Snowfall API. You do that, you just kind of click, create, add a name, add a secret. Within R, you can then use the sys git end and grab your secret there and use it in your code. GitHub's pretty diligent at making sure they suppress these secrets if you try to print them within your logs, and they're doing a pretty good job, because believe me, I've definitely tried to print my secrets. One of my general recommendations on getting ready for your first GitHub action is to start with something that somebody else has made and then kind of modify it and go from there rather than creating from scratch. But in the process of putting this together, didn't find one that had everything I wanted or was totally up to date. So I've got one here that you're free to use, and I plan to use for something going forward. But it has all the basics here within this repository that installs your packages, installs R, runs your script, saves your data, and does Cordo if you would like to. So a few highly recommended resources is David's R for the Rest of Us tutorial, as well as a couple others here. So with that, I hope you have fun supercharging your work with GitHub Actions.
So next up, we have Dror, which I have to do the announcement. The Dror has the amazing accolade of having presented at every Cascadia R ever. And it's always something different and something interesting, so I'm excited. So as soon as his slides come up, it'll be. Now we have Dror.
Thanks. From frustration to function, tackling the challenges of new tech adoption. My name is Dror, to pronounce like a drawer in a desk. I'm an independent consultant. These are some of the places I studied, worked, including University of Washington, some click industry, and more recently, pharma of all sizes. Today, I'm going to talk to you about my journey with Quarto extension called Closed Read for scrolling telling. I'll briefly introduce the tool and describe my first attempt, which unfortunately was not successful. But then I came up with a new motivation. There was a contest for people to submit their projects with that extension, which was a success. So I'm going to share with you the lessons I learned through that process. A disclaimer, this presentation is not about teaching you how to use the tool. The goal is to inspire you how to be resilient. So this is the tool. Basically, you go to closeread.dev gallery, and because it's fresh new tool from August 2024, at that time the developers had two examples, which I'm going to briefly go through. Basically, it's a rendered HTML document, which is split into two sections. So one section is where the user scroll down, and on the other section, things happens. Things that like images, other text that pop up dynamically, as all you do is scroll down. here's an example from the developer example. I scroll down to the left, text is moving, and whoa, all of a sudden, zoom in, zoom out. Another example from the repo, you scroll down, you read it, and whoa, an image. And you want to zoom in. You just scroll down and it's popping into your eyes because the developers wanted to tell a good story and get your attention to where it matters. So I was thrilled after seeing these tools for the first time, and I came home and I said, yeah, I'm going to try it myself. So here's the basic how it's done. You just scroll down, and in your Carto editor, you add tags with the @ and then some tags refer to just text sections, some to images. And if you put multiple text images, you get a nice animation-like visualization experience. Not that hard. Here are the different terminology they introduced in order to do that. So they call it triggers, sections, and stickies. And there are supposedly 3 steps to do that. First, you install Quarto. You install the Quarto extension called close read. Then you run it on your desktop, which for me was just, hey, I want to do the hello world, which was copy paste with these 2 examples that were available back then, and execute Quarto. And lastly, you want to publish it. You could publish it many places. I choose to publish it on GitHub with git push and GitHub pages. So first 2 steps were a success. For some reason, I failed with the 3rd step, right? Maybe something on my setup, maybe it was my laptop, but it failed, right? So even though that should be kind of like just simple steps, right? 3 steps that most of us doing with all over the day. But when it failed, in my mind, it was something a little bit more complicated, right? Something like that, right? And it was hard for me to figure out exactly where the error was. Is it specifically because of the extension? Is it something else? I couldn't figure out at that moment. And I was frustrated and I seek for help. And then you would say probably, okay, we have a great community. Look for a solution in Stack Overflow, the forum, the GitHub repo, or even reach out to the creator, or even ask an LLM. But keep in mind, this was just a fresh new tool, right? There was not much of community and documentation around it. So that's also kind of like what I was frustrated. So taking a step back, right? So this is an innovation tool, right, with Quarto close read. And I guess the developers wanted it to be more adapted. So people like me will not be frustrated and could easily find the solution and tell about it. So it's more popular. And that's why they gave these 2 easy, welcoming, hello world examples. But there were only 2 examples, right? So they figure out, okay, how do we make more adoption of this tool? And then they announced a contest. They said, we're going to ask people to submit their projects, and we're going to motivate them with a great incentive, which is stickers. So I was like, where do I sign up? So I needed to look for some cool ID for my contest submission ID. Where do I find those IDs? Well, I do have a blog. So maybe something related to my blog post. This is one of my early blog posts from 2018 about machine learning, meta machine learning packages such Carrot and MLR and Superlearner. And only a year later, 2019, about ID models, MLR3 and Teal. And in these blogs, I also go back to a classic paper from all the way 2001 by Leo Brayman called Statistical Modeling the Two Culture. So go back in time to 2001, people cared less about R versus Python versus stuff. What people mostly care about statistics versus machine learning. And this is legacy paper, what the author was kind of like trying to annotate and describe. So that paper back around that time was a sensation. Everybody talked about it. Everybody knew what are the two cultures. And for me, it was first challenging to read that paper, but I still find myself every now and then kind of like go back and try to read it again and see kind of like how could I better understand it in today's retrospective, and what type of insights also kind of like that already was relevant to today's technology. So now I had this legacy paper. Also, what's happened recently, I have a new best friend, ChatGPT. So I no longer need to find other people who are passionate about that 2009 paper. I could consult with ChatGPT. And these are the burning questions that I asked ChatGPT. Give me the gist of that paper, right? But I was also curious, why did Brayman choose the term data modeling rather than frequentist? Another burning question, kind of like Bayesian versus frequentist, right? So I was curious, why did Brayman omit Bayesian statistics as a potential for its culture? That was the year 2001. Now I have someone to ask and get the answers. So back to our Quarto and close read. I have an idea, which are my burning questions. I had some paragraphs, ChatGPT answers in just text. I wanted some visual aids, so I asked ChatGPT to give me a summary table, which it did simply. And I also wanted some special effects, and this is where this scrolly telling came about, right? So the idea was the skeleton, the paragraph was kind of like the muscles, the visual aids are the skin, and the special effects are the attire. But something is still missing. What would make the content even more approachable? Something like animation likes to dumb it down, right? So something that makes it accessible to others who might or might not be interested about that legacy paper. And here's another YouTube, if you not, it's called Statistician, talk to biologist, something approachable. And then I also remember that one long time ago, I went out into the Stack Exchange GitHub repo, which has a fictional chat between Bayesian, frequentist, and machine learning, which make it more accessible. So I thought, okay, this is cool, authentic text, not generated by AI, so it's actually valuable. How do I make that? How do I make that? Embed it in my blog post with Quarto extension that is accessible. So I thought, okay, here's the Bayesian. Instead of just the letter B, I'm going to make it a cat. And this image was created with AI tool. Here's the frequentist, and here's the ML. What if I make some visualization of all of these people meet in a bar and chat about these tools? So that's what ended up in this blog post called the 2 or 3 cultures. Here's a brief screenshot of what's ended up. So I tell the story. Here's the classic paper. On the right side, I have my floating text with images pop in as they go, machine learning, Bayesian, the contest. If the user doesn't want to read those, all they have to do is just simply scroll down, answers to my burning questions. And here comes the fun part, right? So now I said, here's the text, but let's see how I animate the iterations. So basically in the tool, you copy paste each of those sentences, you add the tags, and they are pop up. So there are over 100 sentences. I will fast forward that for you. And I'll show you how I did not copy paste each of one of those 100 sentences. Instead, I use a programmatic tool, which is what Quarto is all about. So finally, some R code. So our text is just simple text file with 3 fictional characters. And I wanted somehow to loop by character and add the special effects and the Quarto extension symbol. How do I write a loop in Quarto document? I'm going to use a meta programming. So if you ever try to make multiple tabs in Quarto, you could do it one by one, but there is a trick to that. You render the text with the result as is, and then you put the hashtags which are rendered by Quarto into those tags, just because it's interpreted as is. So I thought, how about I do the same trick with the Quarto extension for close read? Just instead of those hashtags and closing them, I'm going to use the @ and CR. And surprisingly, it worked. So break down the task into smaller subtasks. I combine each sentence from the text with the @CR tag. I print it as a long string, and I embed it in a Quarto document via the result as is chunk option. And that's the text. Basically, I read the text line, I do some wrangling, I add the tag here in red, and I print it. And that's it. So that was a fun thing to programmatic solution for me to not to copy paste. An epilogue. right? So I think it's a great case study of tool adoption, right? So it started with a cool, innovative idea, announced to the world, and had its own passionate early adopters, but maybe not enough. So even though it did get some buzz, mostly social media, there was still not high enough adoption, which also correlated to documentation, example, and community support. The contest did give it a boost, right? It was supposed to increase engagement by incentive, examples, and community, and even post-contest. Now there are at least 100 submissions that have really cool use cases. Some person even made a meta shiny editor for users to do that together. Some of those submissions have really nice special effects and even use of observable in this technology. So my ultimate goal of writing the blog was to make it interesting, right? Or at least not boring, simple, and accessible. So I asked myself how to transform a complex technical topics into accessible, engaging resources for broader, less technical audience. So here's some observation. You might disagree that with LLM AI, expertise in a specific domain may not necessarily be a prerequisite for sharing valuable insights. So perhaps a combination of asking the right questions, along with employing effective storytelling, along with LLM-generated content, good enough LLM context, may result to some usable insights which are accessible and simple, right? So we used to be kind of like in this situation, paying 5 cents, but now maybe there is a tool that could get it for cheaper with AI, LLM. Here's some fun meta discussions, self-reference. So here I was using an LLM tool for reflecting on one of its own creators. Meta-programming in Quarto, which does invisible loops, creating code chunks programmatically, dynamically generate code and context by treating code as data. And perhaps this entire presentation, storytelling about how to do storytelling. Finally, tips, lesson learned. Keep it simple, isolate, and reduce cognitive overload. So when you look at someone's code the first time, you might be, whoa, like you were overwhelmed and you said, no way, I'm not going to do that. But you break it down, right? You isolate, reduce cognitive load, and you figure, oh, no, I can do this. I can put the pieces together. Start with a simple hello world, just as I did with this Quarto extension case. Break down the task into small incremental independent subtasks. Understand the various steps and also understand the connective links, right? In my case, the issue was the connective links, how this Quarto document, for some reason, was not successfully rendered on the GitHub page. Each time modify just one part of the pipeline and then test to see if it's still working. This is called isolate and test in isolation. Beyond code, right? Isolate other possible, what statisticians like myself call confounders, right? Is it related to the operating system, Windows, Mac, Linux? Is it related to your IDE that you're using? Is it about the version or the packages of the R or other dependencies you know, or literally something you don't know that you don't know? Give yourself a break, right? Reset, try again from fresh, clean slate, be resilient, right? No need to reinvent a complex solution. It's okay to adopt a working solution from another, even distant domain. And lastly, community matters. And even if community has still not emerged in this example, start it yourself. Thank you.
Thank you, Dror. Oh, the things we will do for hex stickers, right? So now we have some time for some questions for the 3 speakers from this session. We again have the amazing holders of the microphones.
There is at least one question in the chat.
Yes.
Yeah.
Cool. So one question for the GitHub Actions talks. How many of the free 2,000 minutes per month do you regularly use? Have you needed to pay? Have you needed the paid tiers? Does the setup of R and packages in a virtual machine each cycle take a lot of time?
So yeah, I think you get 2,000 minutes for free. I have never used 2,000 minutes or gotten close. I haven't totally tracked it, but a lot of kind of my size, little, run a script, do a few jobs, it takes between 2 and 3, 4 minutes. So if you're not doing those many thousands of times per month, it's pretty easy to stay below that 2,000 level. But yeah, I think it's a pretty generous free tier, but more advanced use cases definitely can push you to that limit.
Thanks a lot. For Jonathan, you mentioned that one strategy that worked for RStudio is to put the engineers in contact with the users. So I wonder if you can unpack what kind of specific ways have you used to put engineers in contact with users?
So the question was, how do you pragmatically connect engineers and users? So we have a number of techniques that we've used. One of them is we actually have a rotation of engineers, and the engineer on rotation actually just spends their time on our GitHub issues page and our support forums and our discussion boards. So you just get a turn once every few weeks to interact with users. I mean, anyone can do it at any time, but we find it's really helpful to have someone who feels like it's literally their job to go spend part of their day interacting with users. So that's a thing we did in RStudio, and it's also something we do for Positron. So again, if you file a GitHub issue on Positron, you will hear from one of the engineers who makes Positron pretty shortly. So that's one technique that we use. Another is on the kind of more enterprise software side is product support. So when we have users who are having problems and bubble them up through our support system, we have engineers, again, it's a rotation, who basically need to get on the call with the support team and often get on a call with the customer themselves to sort of sort out the problem. And let me tell you, there's nothing that prepares you for the first time you see someone actually trying to use the tool that you made in the wild. It is a humbling experience.
Well, we have one more online that got some chatter, but to share with those in the room, I think we should read it out and get some thoughts. You want me to read?
From Miranda, could you use GitHub Actions to automatically update data files linked to a Shiny app, or is there a better tool for that?
I'm not a major Shiny developer, so if somebody else has the correct answer, let me know. But I think in general, if you just need to update those source files that Shiny accesses, seems very much within the realm of things that GitHub Actions could do.